I'm Brandon Cross. I'm the president of Node of Texas. And today I'm going to talk briefly about the private cloud and the whole cloud in general. You know, there's a concept on the internet that you run across frequently right now, and you'll see it all over the place. You'll see it in advertisements on TV, cloud this, cloud that. What is the cloud and how does it work? Why does it matter? Why should you care? Really, all the cloud is a extension or a greater adoption of technologies we've been using for a long time. You've probably used cloud-based technologies from almost the whole entire time you've ever used the internet. Think of Hotmail, Yahoo Mail, web-based webmail services. Those are a lot of times considered cloud-based. Any time that you have a service you're connecting to that's completely hosted out on the internet and you don't necessarily have control over the data, but you're getting access to your specific set of data and running this application, typically that's when you start to get into basic fundamental clouds. Now, it goes a lot further than that, and the cloud, the term cloud, has become much more important I'd say in the last 3 years really, where these types of technologies have become core to the way data centers are being built. So the whole entire way the internet is being engineered is changing dramatically right now. Some people say that the operating system is less relevant than it used to be. The web browser is where it's at. Things that are running inside of the web browser are more important. For example, take Flash. You can build a whole entire application around Macromedia Flash and run it, and that can be a cloud-based business. You may say that things like the Zynga games, like Farmville and all those games in Facebook that people see that are Flash-based, those in a lot of cases are running in the cloud. Now, how does the cloud work, and what separates today's cloud from yesterday's hosted infrastructure? It comes down to how it's engineered. So, just looking real briefly here, let's take a data center. Many people are familiar with these data centers where they where they host servers, and let's buy us a hosted server, okay, right? So these data centers contain lots of racks. And these racks, inside of each of these racks, are just full of servers. So what you have is you have all of this computing capacity and power here, right? And so this user here wants to buy some of it. This guy wants to buy a server. This guy, might need a couple of servers, whatever it may be, right? So, and this guy is doing the same thing. So here we go. A user or a business, let's say, buys themselves a hosted server hosted at a data center. Another business does the same thing. Another business does the same thing. Right? Maybe this guy, needs more than one. He buys up a couple of these things. So you're running these servers all the time, individually. If this physical server fails, right, if it goes down, then this company is technically kind of down. So reallocating this server's load onto another server isn't something that just happens. It might take some administrative action to make that happen. If this guy needs more capacity than he has, then he's going to have to buy a whole nother server. Maybe all he needs is 5% more capacity, but he's going to have to buy 100% more capacity, because that's how it's sold, is by the server. So you're allocating a whole entire piece of hardware, which ends up getting powered all the time, 24/7. It's being powered. It's always there. It's persistent and it's constant, right? This is the traditional model. Now, looking at how data centers are now being built, there's a big difference. They still have the racks and the servers, But instead of the racks and the servers instead of the individual servers being sold, each server being allocated one server per, this guy, maybe he needs 2 servers, but the whole server gets allocated. Now what they're doing is they're building data centers where it's just a lot of servers that are all interconnected and that are all running as like one big server. So we have to look at this as a solid. Whereas if we look at this, the traditional data center models from years past, we can look at like honeycombs. Okay, there's a lot of little pockets inside of these things. Each individual pocket is allocated to an individual person. Whereas in the solid block here, we might have a whole entire Walmart-sized data center that's just nothing but motherboards and power supplies just all strapped together, operating like one big supercomputer, right? So then we might have a user that needs to buy into this, and they might be allocated a block based on what they're using, what their actual needs are. And if they're not using their block for, let's say, some period of time, then their block might be powered down. And if you have another user who also has a block, they may need a very, very small block. They may not even need a block that's even the size of one server. They may only need like 5% of a server. So what you're able to do in the cloud is you're able to allocate these resources based exactly on what the consumer needs and specify all this power just to them just when they need it. So whenever in a cloud, whenever somebody needs more or less, it can be dynamically reallocated across this solid. Instead of it being allocated once, it's allocated as needed. If the workload doesn't need to exist, it can be powered down, and the consumer or the business isn't paying for that workload. So that's kind of a little bit about how the cloud works differently in terms of data center design and how they're changing the way that these applications are being built and run, and how they're allocating loads across the data center. So now when you have a cloud-based service, a lot of times you can be connected into a cloud-based service in one of these older data centers. But the newer ones are designed to be more efficient like that, because now instead of having 100% of the resources that you could use allocated to you 100% of the time, we're allocating a fraction of we're allocating 100% of the resources you need 100% of the time that you need it. But we're not allocating you 100% of the available resources to us for you all the time. 100% of the time. So if you need to access, if you need 80%, if you need an 80% capacity increase for 10% of the time, that's possible to do in the cloud, for example. Whereas in a traditional model, you're going to buy 100% of what you could use and pay for it 100% of the time, whether you're using it or not. You might be, using 5% of the capacity of your server 80% of the time, and only 20% of the time you're using 100% of it. So you need the 100% of it for that 20% of the time, but you're still paying for the rest of it when you could just have it scaled down automatically. That's part of the cloud. That's part of how the cloud is operating and changing, the way that these systems are being built and how they're being allocated. So anytime you can move your applications into one of these bigger data centers, you're moving into the newer way of doing computing. You're not running your applications on your server just for your users necessarily at your site, right? And then having your server maybe connected to the internet, and then having end users connecting to your server through the internet so they can get to the data sets that live at your office. And what we're doing here is we're allocating a workload for the company, and then basically everybody that needs to connect to that workload, that workload's connected to the internet, so everybody that needs to plug in and use that, they are accessing it at the data center. Now, you may have an office, over here, and you may have a bunch of employees at your office that have an internet connection that are accessing your application that's living in this data center that's somewhere else, and you don't know exactly specifically where this data center is. So now your data is in this secured off-site location instead of at your facility. That's a big difference in how the computing is being done here going forward with things. There's some people that are concerned about privacy and security in these models. I would say that, in my humble opinion, the security and the privacy inside of the big data center solids is going to be vastly superior to the vast majority of especially small business networks out there that are operating. Small business networks specifically have a difficult time making the investment into the higher security levels that really we say should be standardized on. But is an IT guy going to walk away from a job because somebody's not willing to spend an extra $20,000 on security or $5,000 on security or something like that? There may be cases. I've certainly walked away from jobs where I had to maintain a certain level of security in the network, and the customer said, no, we want our network's costs to be lower, so we're going to forego that extra security. And those, the only cases that I know of where I've literally said I can't do this job is when I run into that and there's a regulation, about it, some kind of government regulation that says, no, you have to have your security set up like this, HIPAA compliance, PCI compliance. So those are some examples there. But for the most part, networks that are running out on, in the vast majority of the communities and cities across this country are very insecure as it is. So the thought of data security and where your data is warehoused as being an issue inside of one of these larger data centers really is I wouldn't say it's humorous, but it's probably not as big of a concern as the business owners should be having already with how their networks are built today. So they probably get a step up. I'd say the vast majority of businesses are going to get a step up in their security just by moving into this environment when there's a fear that there's a step down in security. There could be a step down in security if a very large company that has extremely tight controls over their security comes in and says, we want to move all of our systems into the cloud. Now there may be some kind of issue they need to worry about and how their users are connecting to this remote data center. But in terms of this guy accessing this guy's data, one guy's instance accessing another guy's instance, it's designed explicitly to prevent that. There's a great amount of security that's in place to prevent that. Not that it couldn't technically happen. Anything's possible, but for somebody on the street to access any given business's data at their facility where their data is stored securely is inherently simple, extremely easy, and frighteningly easy to do. So just storing your data here is a better thing anyway. Moving forward, going into the cloud environments, I think we're going to see a lot of these concerns go bye-bye. The cloud is going to change how people do computing and how data is stored, how IT systems are built and invested in. What if you never had to buy another server again? What if your server upgrade was an upgrade to the cloud and that's it? Now you never have to buy another server. So this is a little primer on the cloud. I hope you found it interesting and useful. And at Node, we perform cloud services for our clients and integration into the cloud. So we look forward to finding a way to serve you and provide your business with cloud-based services.